Yes, so welcome. It's good to have you here. And we're going to talk about two skills. First one is conditional probability. The second one is inference, for example, statistics. We'll spend most of the time on conditional probability. Now we're going to do some inference and sample statistics. There aren't much exercise in here, so the whole skill is encompassed in 16 or 15 exercises only. This should be nice. Perhaps we should start with this one. I think it's the longest one. So maybe I'm not being so nice today. So the goal of the skill really is to find a way to make a meaningful conclusion about this set of data that's being displayed. So what can we say for sure about these people by knowing just this amount of data? It's really the question.
Technically, both A and B can.
Technically, both A and B
Is it like can we choose more than one?
No, I think in the SAT you need to choose just one choice. So you're saying it's either A or B. Well, maybe you can walk us
I would
through.
say
Well, let's see. Can you walk us through why you think this?
first of all, they say based on all of this data that 30% of US teams who are heavy textile. And also they said there's an associated margin error of 3%. So that means it can be 33%, and also it can be 30%. It can be 32%, whatever.
So there's a margin of error. So
Yes.
it's 30% plus or minus 3, probably.
Yeah.
Okay.
So that means also that maybe 3% of the teams who are classified as heavy textile are not really heavy textile. And also it can mean that 3% of classified teams who are not classified as heavy textile are actually heavy textile.
Okay, let's focus on the first one, right? The margin of error is 3%. So it could be approximately 3% of teens are not heavy textile.
Yeah.
But it could also be approximately 2%.
Yeah, that.
And it could also be approximately 1%, because it's you talked about the margin of error, right? So we're not sure. We know we're in this interval, but we can't really say for sure. 3% approximately will always be not heavy textiles, because it could be 2%. Because in reality, we could have 2% or 1% who are not really heavy textiles.
This is I didn't see correctly. See
It's C. Okay. Well, let's see. It is not possible that the percent of all US teens who are heavy texters is less than 27%. Why do you say that?
Because the margin of error is 3%. That's it. It cannot be like less than 27%.
Okay, so you're saying that if the margin of error is 3%, then it cannot go lower.
Yeah, because in the study they said it's estimated 30%. So it's either 28, 27, 29, or 31, 32, 33. That's it.
Okay, but do you know that the margin of error is also a prediction?
Yeah.
So it's not fixed in the sense. So the margin of error could be wrong. So you could have statistically with low probability, but you could have a case where, let's say, the actual number of people who are heavy taxes is much less than this 3% threshold. So when I say it's 30% with 3% margin of error, this should encompass most of the cases, but not all of them. This is more or less something like a definition.
This is a good question.
Right?
Yeah.
You see what I mean?
Yes.
Then it's deep.
Okay, you've gone through all of the questions now. But it's good. Okay, maybe deep. Okay, let's just let's just finish off this part.
But they said it's doubtful. Like most likely it's not. That's what they say. It's doubtful. So that's why it's deep.
Yeah. So you're saying because there is. So when I say doubtful, I mean it is possible statistically.
Yeah, it's possible, but most likely that's not.
I mean, I'll argue against that because So let's go back to this point and make it very clear. So when you say 30% plus or minus 3%, this should encompass most of the cases.
Yeah, that's it.
But not all. But most of the cases, the majority of the cases, should be in this interval. So 35% is 30% plus 2, right? 30, sorry, it's 33. Sorry. 33%, or was it 30%? Uh-huh.
30.
So yeah, so it's 30 plus 3. So I think, okay, yes, you are right. So I think I misread the percentages. But it is indeed doubtful because we know that most of the cases, so this is also related to this other point. So this covers most cases. Most likely we will be in this interval. So if we go outside of that interval, statistically, this is unlikely. This is what we mean when we say there's a margin of error or there is a lack. So I would agree with you that this should be the answer, but I would like to see maybe what you think about.
I think so. Detail.
Yeah. Well, let's take a look at why it's not C. So we know it's not A. We know it's not. Oh no, we know it's not C. But why do we know that it's not B as well?
Because it's gonna be like 33%.
So we don't know for sure.
Yeah.
Because this is when I say the percent of all US teams who are heavy texters instead of 3%, I say with probability 1, and that's a lot of confidence. Yeah. Should be able to back that up with the data, but the data says otherwise. Then this is more assertion for us that this is indeed the answer. So yes, I would agree with you. This is a really good text. It's a really good one. So maybe let's do another one. I think it has the same flavor, but do keep in mind that when you talk about sample statistics specifically, we do this because we're not able to talk about the whole population. So it is accurate to a great extent, but it is still speculation in the sense that you don't really know the absolute truth. But with with high probability, you can say this event is going to happen this very specific interval or this specific set of values. For example, you always get the intended outcome. So, for example, here you have 300 million people in the United States, but the sample data is only for 411. And so it cannot really represent every single US citizen in that case. But it can try to. That's why it's always probabilistic. There's no absolute certainty in the sense.
So that moment they can.
Are we missing one of the?
Yeah,
We have strong in favor.
yeah, it looks like it. Okay, that's good. That's a good note from myself. But I'm comparing the question here. So my apologies for this. Strongly favor. Oops. Okay, maybe I'll put it here. From a favor is how many people? It's 36. So the question is actually missing. It's 8. I'll probably change it afterwards.
Do you know what they ask in this question? They need the ratios, something.
So this question asks you to solve the problem. So the problem here is we want to get an estimate for how many millions of Americans so we want to get difference between the number of US residents who favor nuclear energy against the people who oppose it. We want to get a rough estimate of that. We use samples. So we have the sample statistic. We have, in reality, 300 million people, but we're only interviewing 411. So just from this small sample, we try to make some inference about the whole population, because we can't really go and knock on the door of every single American that's out there and ask them about your views on nuclear energy. So that's always the goal. To use sampling to be able to represent the population. If you do it well enough, then you can get good estimates. In this case, we have these people who favor nuclear energy and these people who oppose nuclear energy. So the sample yes, so the goal is to find the number in millions. First thing we need to find is approximately in millions. How many people favor nuclear energy? Be it strongly or somewhat. That is a question for you.
197,100,000.
Already. 997 million, 100,000. Okay, that's because this is obtained from the ratio of the sample. So you take the ratio of the sample, which is 411 people.
let's say 94 million.
Oh, you already have the answer.
Yeah.
Okay. Let's see. So we are here. The ratio between people who favor nuclear energy to everyone else is 214 plus 56. That's the ratio. You find this amount of people out of how many people? Out of 300 million. I think the million is just yes, that was correct. And you get this number. So you use the sample statistic and you make the assumption that it mimics the behavior of the whole population. You do the same thing for the people who do not favor nuclear energy, or you could so there are two ways you could do this. You could compute it. People don't favor, so oppose. Here I'll move NE because I feel like it's distracting. So you can either write it as follows. So you would get some value here, and it will be the sum of the two other values for the people who oppose. So 104 plus 37. These are the people who oppose out of the 411. You would scale that to the whole population. You should get some number. And this number should be close to 300 million minus 197 million, 100,000. Logically speaking. You don't really need to compute both of them. And actually, I will not compute it. So what I'm going to write here is I'm going to write 300 million. I think that's 300 million. Yeah? And I'll take away 907 million. I'll get 102 million people, roughly. And now when I take away these two values, what do I get?
93,900,000. You round it.
So 93,900,000, you're saying. Yeah, which is now in millions. So you want to provide your answer in millions. That's what we need. So this is a good question. Just need to take things slowly, and then it is clear. So what we did here is we make the assumption that the samples that we picked exactly mimic or very closely mimic the behavior of the whole population. So we say if 214 plus 56 people out of 411 are for nuclear energy, then I take this ratio and I say, okay, if I apply this ratio to the whole population of the United States, what number do I get? And I get this. I get 197 million. It's like saying I'll choose 214 people plus 56 out of every 411 people in the population of the United States, if that makes sense. So for each 411, I will assign the value of favor to 214 plus 56 people. Yeah, this is a bit obscure, I feel, but I hope the idea is maybe it's a good idea to do one more exercise to brush up for today. So I'll wait until you get a solution. So this is the same scenario really. You have 1,800 people in the 8th grade, but we just look at a sample of these people, which is 26 students. And we'll assume that this class, this random class, will represent the whole population of 1,800 people. Well, not 1,800 people, 1,800 classes, even greater. So we're not looking at 26 students. So we have one class, which we will assume that it will represent all of the other classes. And from there, we'll see what we can infer from the data. So maybe it's a good idea to start by focusing on what happens in the class itself. 34.6 people out of 34.6% out of the 26 students has at least 2 siblings.
Say B.
B, okay. Let's go on. Why do you think the answer is B?
It's pure.
No, okay, I'll wait a minute.
We always word it.
It's not me, it's college board.
Yeah.
So 34.6 people, percent of the students, has at least 2 siblings. So how much percent have less than
D.
less than 2 siblings? Right now we're in class. We're in Mr. Camp's class, and we know for sure that 34.6% have at least at least 2 siblings. When I say at least, so it's 2 or more.
Yes.
It's 2 equal or more. Then what's the percentage for people who have less than 2 siblings?
0.64.
0. I'm asking for the percent.
65.4.
65.4. Because these two are exclusive, they don't intersect. So
It's D.
it makes perfect sense to have this. Okay, so that's the percentage of people who have less than 2 siblings. This is in class. This is what happens in the sample.
Yeah.
Now let's scale this to the whole state. So they are representative. That's the assumption we need to make, at least to be able to make an inference. So, because if the sample is not representative of the whole population, then you're making bad inferences. Okay. So we have this. There are 1,800 eighth grade classes.
Each class.
And each class on average has 26 students. So 1,000, so on average, we have 1,800 times 26. students. How much is that?
46,800.
Times 26. Oh, I'm sorry, 26. Yes, you're right. Maybe I should trust you. So 46,000.
Don't trust me after the
Okay, I won't trust you. And then finally, we don't want all of these people. We just want the percentage of them which will have greater than 2 siblings. So that's something to keep in mind for you. And so we take 65%, or roughly, of this 46,000 student population, because we assume that the sample represents the population. And that gives us roughly, I don't know, you said D?
30,600.
Okay. Should I trust you?
Yeah.
Okay, I trust you. I won't trust you. You trust him? Okay, you trust. Okay, that's good. It's good to have trust in people.
They hate college board how they board. I think I only did 34 because I thought they want to have at least 2 siblings. Then I said no.
You would choose that. Yeah.
Then I fixed it.
So you need to be careful in that regard, because if you're not, you lose points, and it's bad, because you spend time with the problem. Time is very
You
valuable.
understand the solution.
It's very valuable in SAT. If you miss the question, you miss it. Okay, you go about it. But this is very good. So we were able to do, I think, 9 exercises, which is it's great. I don't know if this is a glass record or something, but this is a lot of exercises, and I'm happy about it. I hope you're also happy about it. I'll be here, of course, if you have questions. And I highly encourage you to try to do the rest of the problems as soon as you can. Not today, because I think it's already 10. No, so you have to stay up and do math. I mean, subjectively, this depends on each individual. But then, if you do them very soon, then you'll be able to really cement the ideas that we've discussed today in your minds. And with this, I would like to conclude for today. Thank you very much. And it's been an absolute pleasure. I hope to see you on Wednesday. Yeah.
Wednesday is our last meeting, correct? We don't
Is
have
it?
another one past that. I don't think so. I think Wednesday is our last one.
No. I think it
next week
extends
is the last
to
one?
December. When is the SAT exam?
September 7th.
December 7th. So I think we're going to meet on the 2nd of December and the 4th of December to finish off some geometry.
Yeah, it's
So right now, we're almost done with problem solving. We only have 3.7, but then we need to do some geometry because it appears on the exam. But if you feel like, of course, if you feel like you're good enough on geometry, then you don't need to.
Good book says that.
Okay, then you should show up early even, or and do the exercise. By the way, you can do this. The exercises are already uploaded on Moodle.
Yes.
You can attempt the easy exercises, come ready with your questions, you talk about it, and you get a better opportunity to collect more info about.
I think they just said I'm bad because there's only maybe 9 questions which are here. So higher percentage if I get something wrong.
Yes, I think that's the case. I think only 15% of the exams on geometry.
Yeah.
Something like this. It's not really a lot of questions, but it can be the difference between a good score and a bad score. So that's important. Yes, I think that is enough. And maybe you should stop recording.